Good morning. Today we're going to talk about additive volume because it is Wednesday, which is going to be very similar to the topic we talked about yesterday with our double black diamond. And that's because that plus sign that we were finding the volume of is going to be very similar to a lot of the questions that we see today, but with a little bit less, conversion and things like that, because we want to make sure that we're getting the basic idea and not just the most complicated ideas, or that if you are lost on the most complicated ideas, that you can kind of circle back and do these easier ideas. So with that, let's talk about additive volume. And I forgot to fast forward. All right, here we are. So the bunny hill says, calculate the volume of each of the rectangular prisms below. Write the multiplication sentence for each. So I'm not going to do these on my whiteboard because I think we've hit multiplication at this point. I think we've hit volume at this point pretty well. If you have any questions, and if these questions right here are confusing or difficult for you, I want you to send me a text message, an email, whatever, right now. So if you cannot do these first three questions, that is a red flag. You should let me know right away. All right, so let's continue on. So you should be pausing this video, doing these three questions. If you are here with me now, you should have finished those questions, and we're going to go through the answers. So the answers here for this bunny hill are number 1, 729 feet cubed, and this multiplication sentence is 9 times 9 times 9. Remember and notice that you can keep going through that video, memorize it, make sure you are very familiar and very aware of volume and all the things that go with it. Volume is length times width times height. Volume's easy. Oh yeah, length times width times height. Length times width times height. So if that's stuck in your head, you're multiplying the length times the width times the height of all of these. So that would be 9 times 9 times 9, I think was the question. Yeah, 9 times 9 times 9. So this is actually a special kind of rectangular prism called a cube because all my faces are the same size. Number 2, the volume is 30 yards cubed. Our multiplication sentence is 3 times 5 times 2. Number 3, our volume is 180 inches cubed. Our multiplication sentence is 5 times 12 times 3. This one you might be like, why is it times 12? Remember, the first thing you should do in any volume question is look, are my units the same? Because if they're not, you need to start with conversion instead. Moving on to our hot cocoa break. So it says, find the volume for each of the situations listed below. Most important thing for a question like this, just like any word problem, especially word problems about geometry, is we need to make sure that we draw this on this lovely board or on a spare sheet of paper, that we're not just trying to visualize it in our mind and put the numbers where they go. So I'm going to walk you through each of these. You can either do these with me or you can pause, attempt to do these by yourself, and then come back for the answers and the explanations. So up to you. The first one says there's an ice cream carton that takes up 3 inches by 9 inches by 7 inches. So I'm going to draw that. 3 inches by 9 inches by 7 inches. Let's see if I did that correctly. Yay! So we have 3 inches by 7 inches by 9 inches, essentially, okay? Now remember, because this is multiplication, because we have the commutative and associative properties, we could have drawn this a bunch of different ways, right? This would be just as accurate if I just drew it on its side, right? So let's say if this was 9 inches, this was 3 inches, and this right here is 7 inches, okay? It's the same figure. They both take up the same amount of space, and so it doesn't really matter how I draw it. What is the most important thing is that I have drawn it, and I've drawn it accurately. Okay, so now, as usual, I need to multiply length times width times height. So, and let's go back to this question. She bought 3 ice cream cartons of the same size. How much volume will it take up in their freezer? So how much volume are they total, all 3 of them, going to take up is my main question. So, but first I need to figure out the volume of 1 ice cream carton, then I can figure out the volume of 3. So we have 3 times 9 times 7. So let's do, I see that I can do repeated addition when I multiply by 3. So I'm actually going to multiply these two together first. So 9 times 7, let's sing it together. 7, 14, 21, 28, 35, 42, 49, 56, and 63. So we have 60. Nope. It's a 2. We have 63 as my answer to this part. Okay, so now I need to move on and I need to multiply this whole thing times 3. So I have 63 plus 63 plus 63 because I'm multiplying it by 3. So I need to go from this way first. So I have 3, 6, 9. Nothing to carry, 6, 12, 18. So my answer here is 189. Okay, pretty easy so far, right? So that's the volume of 1 carton of ice cream. Now I need to figure out 3 of these cartons together. So I have 189 times 3. I'm going to let you solve that on your own because I do not do multiplication backwards. So I have 189 times 3. We multiply the ones. 3 times 9. 3, 6, 9, 12, 15, 18, 21, 24, 27. So I write down the 7, carry the 2. 8 times 3 is 8, 16, 24. Plus 2 is 26. Write down the 6, carry the 2. 3 times 1 is 3, plus 2 is 5. So my answer here is going to be 567. Okay, so I'm not going to go through all of these because that would take a while. To be honest, I already recorded this video and somehow it was lost to the interwebs. So we're doing the best we can with this less than ideal situation. Situation. Erase, 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 erase. Okay. Number 2. David has a lot of stuffed animals. His family is moving and his mom told him that he is allowed 3 boxes for his stuffed animals, each measuring 2 feet by 3 feet by 1 foot. I'm drawing that out. So his mom is giving him 3 boxes for these stuffed animals. So it's 3 feet by, 2 feet by 1 foot. Okay. Yeah. So mine doesn't totally look to scale. And then he has 20 square feet of stuffed animals. So the question here is he going to be able to pack them all? So let's remember, too, that he has 20 cubed feet of stuffed animals. So I'm going to write with a darker marker because I feel like that's part of the problem here. So first thing I need to do is figure out the volume of one individual box. So I have length times width times height. So that means 6 times 3 times 1. Oh, that's much better. Okay, so now because of my commutative property, I can change the order. And associative property, I can change the grouping. So I'm going to start by multiplying these 2 first. 3 times 1 is obviously 3. Copy your whole question down. 6 times 3 is 6, 12, 18. So the volume of 1 box is going to be 18. What I need to do from here is I need to make sure that I'm then multiplying that by 3 because I don't just have 1 of these boxes, I have 3 of them. So I don't know why I keep trying to do this on here. I know it's not going to work. I'm going to multiply 18 times 3. You can do it with me. So we multiply the ones. 8 times 3 is 8, 16, 24. Write down the 4, carry the 2. 3 times 1 is 3, plus 2 is 5. So my answer here is 54. Whoops, backwards 4. Let's check it out. So that is the volume of just 1 box, though. So what we need to do, nope, I lied. That's the volume of 3 boxes. Yep. So it's 54 feet cubed. So he is allowed, so if he has 20 square feet of stuffed animals, will he be able to pack them all? Yeah, he has way more than enough. So I'm not going to do the next couple ones with you because I think you kind of get the idea by now. Let's do number 6. Katie is making a 3-tiered rectangular wedding cake. Her base measures 3 feet by 2 feet by 1 foot. The next tier is 1/2 the volume of the base tier, and the top tier is 1/2 the volume of the middle tier. What volume box does Kate need to fit the entire cake for proper transport to the wedding? Okay, So obviously I know that we don't usually, so we're not going to break apart the cake to fit it into one box. And ideally we would just measure the base times the height. But I do want to show you that it is important because we can find out like the minimum at basic volume that we would need to package this kind of cake. So the reason I put this question in here is because I see students get confused sometimes about the basic words in the word problem. So this one's using that word tier. All that means is a layer of cake. So this is my bottom tier of cake, and it's a rectangular prism. This is my middle tier of cake, which it says is 1/2 of the total of this one. And then this top tier is going to be 1/2 of this one. So you kind of get the idea here. We're going to need to find out this volume, divide by 2, divide by 2, because we're just following a half. So let's figure out what the volume is of this big base. So the base of this wedding cake is 3 feet by 2 feet by 1 foot. So we're going to go 3 feet by 2 feet by 1 foot. Now again, I drew it this way. If you put the dimensions somewhere else, guess what? It doesn't matter. Because of multiplication and how it works, we can still calculate the volume. So first thing we need to do is find the volume of this base here. So what I need to do for this is multiply 3 times 2, right, that's 2, yeah, times 1. All right, and again, associative property means you can change the grouping. Commutative means you change the order, and associative means you change the grouping, and distributive multiply the outside by the in. So I'm going to multiply 2 times 1, which is 2, and then 2 times 3, which is 6. Pause because I forget how to draw 6 backwards sometimes. Okay, so this volume is 6 down here. What would half of 6 be? Oh, 6 divided by 2 is 3, so that's really easy. Oh, and don't ever forget your units, because this is feet cubed. Remember, length times width times height. 3 cubed divided by 2. So that's 3 feet cubed. And then 3 divided by 2, if you think about it, so if I have 1, 2, 3, 4, 5, 6 halves, 3 divided by 2 is going to be 3 out of 6 of these halves colored in. So that's going to be 1.5, or you might have just known that already. Think $3, what would that be divided by 2? There's a lot of different strategies. So this would be 1 1/2 feet cubed. Now you might think you're done here, but you're not. You need to stop and make sure you add together all 3. That's why it's additive volume. We're not just finding the volume of 1, we have to add it together. So we have 6 plus 3, which is 9. 9 plus 1 is 10, 10.5. So my answer here is going to be 10, and a half feet cubed. Let's show the answers. Would help if I put them up. So here are all of your answers. So for number, with my math book in front of me, number 1 and 2, we did together. Number 3, a teacher is trying to organize her tissue boxes on the first day of school. She has 22 students who each brought in a box of tissues measuring 5 inches by 5 inches by 6 inches. She has a bigger box that measures 20 inches by 20 inches by 20 inches. How many boxes of tissues can she fit in the bigger box? She can definitely fit all of them in. It only takes up 150 square inches. She has 22 students, and she could fit 53 boxes inside. Number 4, Sonali is a young entrepreneur. She is selling jewelry that packages into boxes measuring 3 inches by 2 inches by 1 inch. If she takes 12 of them to school, how much volume will they take up in her backpack? That'll be 72 inches cubed. Jamali is excited. His family is going to Jamaica on vacation. Each of them has a suitcase measuring 6 inches by 1 foot by 2 feet. What is the volume of the entire family's suitcases take up? 1 cube foot, or 1,728 inches cubed. All right, so that is the end of this section. You should be able to get the green circle by yourself. I'm projecting it up here right now, so pause and do it on your own. You should be able to do that. Here are the answers. So number 1 is 1,000 inches cubed. Number 2 is 36 inches cubed. Number 3 is 105 inches cubed. Number 4 is 144 inches cubed. And number 5 is 40 inches cubed, units cubed. Make sure that you text me questions if you have them on this one or on the bunny hill.